Morning everyone. Yeah, very good morning. Shall we begin the session? Today's topic is the reduction to the relational schemas. In the last class we have started with the we have covered with the basic concepts of the ER model, how it is built, what are the diagrams that is used, what are the scenarios which is used, what are the figures that is used for the building or making a ER diagram. So we can represent a database that conforms to an ER database schema by a collection of the relation schemas, and for each entity set and for each relationship set in the database design. Whatever the entity set, whatever the database design that is covered. So there is a unique relation schema to which we assign the name of the corresponding entity set or the relationship set. So whatever the corresponding name, whatever the relationship set that is assigned, so there is a unique relation schema. And both the ER model and the relational database model are abstract, logical representation of the real world entity. So whatever the ER model, whatever the relational database model that is using over here, that is the abstract logical representation of the real world entities. And because of the two models employ similar database design or similar design principles, so we can convert an ER into the relational design, whatever the relational design, whatever the procedure that we are following up. And in this section, we describe how an ER schema can be represented by the relational schema, or how the relation will be represented in the ER diagram, and how constraints that arising from the ER schema that is used that can be mapped to the constraint on the relation schema. On the relation schema in the sense that there are various schemas by which it is assumed, by which it is mapped out to the relational schema. So first part is representation of the strong entity set with a simple attribute. So whatever the attribute we are using, that is used with a relational schema. So when we talk about the relationship set, that representation will be done in a strong entity set with the simple attributes by which the schema derived from the single entity or the strong entity sets with the primary key of entity set that serves as the primary key of the resulting schema. So this follows directly from the fact that each tuple corresponds to a specific entry in the entry set. Whatever tuple, whatever corresponding entity we are using out, that entity will be representing in the entity set that will be used with the set student of the ER diagram. And these are the three attributes: ID, name, and the total credit, that is represented by a schema known as the student with three attributes, that is the ID, name, total credit. And note that since student ID is the primary key of the entity set, so it is also represented, it is also known as the primary key of the relation schema. So continuing with the example of the ER diagram, all the strong entity sets except time floats except have simple attributes, and the schema will be derived from these strong entity sets are: this is the classroom, building, room number, capacity; department, department name, building, budget; course, course ID, title, credits; instructor ID, name, salary; student ID, name, total credit. So whatever the classroom's findings, whatever the scenario that we are using up, so that may be contained in the building, that may be contained in the room number, capacity. Then department, department name, building, budget; course, course ID, title, credits; instructor ID, name, salary; student ID, name, total credit. So as you can see, both the instructor and the student schemas are different from the schemas as we have seen. They are the representation of the attribute that is known as the department name. Why department name? That is used as a attribute for which the department number, department name will be established. Next is representation of the strong entity sets with the complex attributes. So, in this case, we represent, so what are the various strong entity sets that have non-simple attributes and things are a bit more complex. So we handle composite attributes by creating a separate attribute for each of the component attributes. So we do not create a separate attribute itself, but we consider the instructor entity set depicted, that is over here, and over means over here, not over here. And for the composite attribute name, the schema generated for instructors also contains the attribute. What are the attributes? But that is the first name, middle name, and last name. There is no separate attribute or schema for the sim or for the name. Similarly, for the composite attribute address, the schema generated contains the attribute street, city, state, zip code, and this is the composite attribute that is replaced by the street number, street name, and the apartment. So we use this complex attribute entity that will be used in a complex scenario. And the multi-valued attributes are treated differently from other attributes. So we have seen that the attributes in an EA diagram generally map directly into the attributes for the appropriate relation schema that is used with the multi-valued attribute that is used with the exceptions, neuro exception schema that are created for these attributes that will not explicitly represented in the relational data model. However, they are representing as the methods in another database model they are using as the object relational database model. And that is also a version of the entity set instructor with the complex attributes without including the multi-valued attribute. There is the instructor, there is the ID, first name, middle name, last name, street name, apartment number, city, state, zip code, data. So for this multi-valued attribute M, we create a relation schema R with an attribute A that corresponds to M and the attribute corresponding to the primary key of the entity set or the relation set of the M is an attribute. This is the example that depicts how the entity set instructor includes a multi-valued attribute phone number and the primary key of the instructor is the ID. So this is the ID primary key. Then for this multi-valued attributes, we create a relation schema. So this is the instructor phone, ID phone number, and each phone number of an instructor is represented as a unique tuple in the relation on the schema. Therefore, we had an instructor with the ID 22222 and phone numbers 5551234 and 4231. So we use the relation schema. That is relation schema have a two tuple that is the 222555124 and 22222555431. So we create a primary key of the relation schema that consisting of all the attributes of this schema. And in the above example, the primary key consists of both the attributes of the relation instructor name or instructor name. And in addition to this, we create a foreign key constraint on the relation schema that is created from the multi-valued attribute with the attribute generated from the primary key of the entity set referencing the relation that is generated from the entity set. So in the same example, the foreign key constraint on the instructor phone relation that would be the that attribute ID references the instructor relation. And in this case, the entity set consists of two attributes, a single primary key attribute B and a single multi-valued M. The relation schema would contain only one attribute, namely the primary key attribute B. So we can draw this relation with the remaining or retaining the relation schema with the attribute B and attribute A that correspond to the M. So to illustrate, consider the entity set time slot depicted over here. Here time slot is the primary key of the time slot entity set and that's the single valued multi-valued attribute that happens to be the composite. This entity set can be represented by just the following schema created from the multi-valued composite attribute. There is a time slot ID, day, start time and the end time. Although not representing as a constraint on the EA diagram, we know that there cannot be two meetings of a class that start at the same time of the same day of the week but ends at a different time. So based on this constraint, end time has been omitted from the primary key of the time slot schema. And the relation created from the entity set would have a single attribute time slot ID. Optimization of dropping this relation has a benefit of simplifying the resultant schema, database schema, although it has a very drawback related to the foreign key constraint that is explained over here. Next is representation of the weak entity sets. How to represent the weak entity set? Just a minute, wait. This is how we can represent with the weak entity sets. So here, let A be the weak entity set with the attributes A1, A2 till AN. Let B be the strong entity sets on which A depends. Now, let the primary key of the B consist of the attributes B1, B2 till Bn. So we represent the entity set A by the relation schema called A, for which or with one attribute reserved or for each member of the set. This is A1, A2 till AN union B1, B2 till Bn. So for the schemas derived from a weak entity set, the combination of the primary key of the strong entity set and the discriminator of the weak entity set serves as the primary key of the schema. So whatever the primary key that is using up, so that the schema will be used for creating a primary key. And we can also add a primary key constraint on the schema. So that schema will be used either as a primary key, either as a foreign key. So for this schema, there is a combination of the derived data type with a discriminator of the weak entity set that also serves as a primary key of the schema. And in addition to creating a primary key, we can also create a foreign key constraint on the relation A that specifies that the attributes B1, B2 till Bn references the primary key of the relation B. Now this constraint also ensures that for each tuple representing a weak entity, there is a corresponding tuple representing the corresponding strong entity. So there is a weak entity, there is a strong entity for which it represents with the ER diagram, it represents with the attribute, semester and the year. Then the primary key of the course entity on which a section depends is course ID. So we represent the section by a schema with the following attributes: section, course ID, section ID, semester and the year. So this primary key consists of the primary key of the entity set course along with the discriminator of a section, which is section ID, semester and the year. And we can also create a primary key constraint in the relation schema with the attribute, course ID, that referencing the primary key of the course schema and the integrity constraint on the delete cascade. And because of the on delete cascade specification constraint, if a course ID is deleted out, so there are associated section IDs also that is available with the entity set that is used with the entity set. Now the representation of the relationship sets, how we can represent the relationship sets, that is used with the attributes formed with the primary key of the entity sets, and let B R with the descriptive attributes of R, that is B1, B2 till Bn. So we represent this relationship set by a relationship schema known as the R with an attribute for each member set. And this we have to choose a primary key for a binary relationship set, that is taking all the primary key attributes from all the related entity set that serves to identify a particular tuple. But for one-to-one, many-to-many, many-to-one, one-to-many relationship set, this turns out to be larger set of the attributes than we need in the primary key. So this primary key is instead chosen as for a primary or for a binary many-to-many relationship, the union of a primary key attribute from the participating entity sets becomes a primary key. And there is a one-to-one relationship set. In this, the primary key of either entity sets will be served as a primary key. And many-to-one or one-to-many relationship set, the primary key of the entity sets will be used as a primary key. And for an array relationship set without arrows on its edge, the union of the primary key attributes from the participating entity sets becomes a primary key. And for an array relationship set with an arrow on its edges, the primary key of the entity sets, not on the arrow side of the relation, that serves as a primary key of the schema. And we also create the foreign key constraint that is available within the data On the relation schema R, that will be used as follows. So with this one, we represent with the R, we create a foreign key constraint from the relation schema. As an illustration, consider the relationship set advisor in the ER diagram of figure 7.15. This is the 7.15 figure. This is the 7.15. There is an ID, there is an instructor that is used over here. There is a time slot ID, there is a text relation, there is an advisor relation, instructor relation over the instructor department, student department. These are the various departments that is used with the IDs with the departments. So there are two parts in this. The relationship set involves with the following two entity sets. One is the instructor with the primary key ID, student with the primary key ID. And since the relationship set have no attributes, the advisor schema has two attributes, primary key of the instructor and the student. In this case, both the attributes have a same value, both the attributes have a single value that is represented within the schema. Since both attributes have a same name, so we rename them as EID, IID and SID, that is instructor ID and the student ID. And since the advisor relationship set is many to one from student to instructor, the primary key for the advisor relation schema is SID. And we also create two foreign key constraints on the advisor relation that represents what are the various relationship in which we are using with attributes IID, so that relationship will be used as a schema as a method for which it is used as a relationship set. So we can also create a foreign key. We can also create a foreign key constraint from the advisor relation with attributes whatever the attribute that is available with referencing the primary key of the student. Now observe that for the case of relationship set prerequisite, we can represent with the schema, we can represent with the associated part that is representing with the schema that is used within the schema of the course ID, department ID that will be used as a set of one or more related tuples, and it is said since each of the following is one-to-many relationship. That relationship may be the entity set, the relationship that relationship may be the entity set in which we are using with the corresponding IT attributes, with the attribute that is given with the foreign keys, that the section and the class terms that teaches with the corresponding IT. We can reduce the schemas, or what is the redundancy of the schemas, that is how we can reduce the duplicacy of the schema. So a relationship set linking a weak entity to the corresponding strong entity set is treated specially, and these relationships are many to one and have no descriptive attributes. And furthermore, the primary key of a weak entity set includes the primary key of the strong entity sets. So whatever the primary key of the weak entity set, that also includes the primary key of the strong entity sets. And in the ER diagram, the weak entity set section is dependent on the strong entity set course by the relationship set course or section course. And this primary key of section is course ID, section ID, semester and the year, and primary key of the course is course ID. And since it is a descriptive, or it has no descriptive attributes, so there is a section course schema have attributes, course ID, section ID, semester and the year. In this schema, we are going to represent with a section that includes the attributes course ID, section ID, semester and the years, and every course ID, section ID, semester, year is a combination in a section course schema relation that will be representing in the relation on the schema section and vice versa. Therefore, the section course schema is written there. And in general, the schema for the relationship set linking a weak entity set to its corresponding strong entity set is also redundant, that is also duplicate, and does not need to be present in the relational database design that based upon an ER model. Whatever the ER model we are using up, that is representing within the entity set, that is representing within the strong entity sets. Then next is the combination of the schemas, how we can combine multiple schemas together. So consider a many-one relationship set AB from entity set A to the entity set B. And using our relational schema constructor algorithm, we get three schemas A, B, and AB. Suppose further that the participation of the schema in relationship, that is entity A, another schema it must participate in the relationship AB. So therefore, we can combine the schemas A and AB to form a single schema consisting of the union of the attributes. Whatever the union of the attribute that is taken out for both the schema. And the primary key of the combined relationship schema is the primary key of the entity set into which schema and the relationship set schema was merged up were combined. So to illustrate, let's examine the various relationships or relations in the ER diagram. One is the instructor department or instructor department, so that combines with the two schemas, that is the instructor and the department. Then student underscore department that combine two schemas. One is the student, one is the department. Then course department, course and the department correspond to the entities A and B. Section and the classroom, section and the time slot. So in this case, we are combining with the one-to-one relation with the relation schema for the relationship set that can be combined with the schema for either of the entity sets. And we can also combine the schema if the participation level is also low with also partial by using a null values. And in the above case, if the institute department were partial, so then we are going to store the null values for the department name attribute for those instructors for which we have not associated department. Finally, we consider the